Okay, we're going to come back and and take a look at further function compositions. We went through this previous slide, which was introducing us as to ways of doing the general composition as opposed to compositions with just a single value. Okay, and that's going to be where we're going to break off from here. Okay, so we're going to take a look at these two functions. Okay, the quadratic 2x squared plus 3x minus 4 as f, and g of x is the x minus 4. Now, let's determine the following composition. We're asked to find f g of x. Well, what does that mean again? Okay, it means we go to the function f, and all x's are replaced with the function g of x. Okay, so so that's what we're shown here in red. Okay, this is the function f with the replaced value of x minus 4. If you think about it, we're essentially evaluating f of x minus 4, which sounds like a translation. Well, let's see if in fact it is, and I'll tell you ahead of time it is. So this is just the initial uh, inserting of g of x as the new x for into function f. Let's carry out the algebra, expand it out, distribute, and see what the end result is. Okay, so the end result is the 2x squared minus 13x plus 16. Now I want to take a look at this from a graphical standpoint. Okay, as we said, okay, you're essentially evaluating f of x minus 4. Again, because all x's are replaced with x minus 4, which should imply, okay, a shift of 4 units to the left, okay, to the right, I'm sorry. So here it is. In red is our original function, 2x squared plus 3x minus 4. And our resulting function from the composition of these two, which is, okay, in blue, and shows to be merely a 4-unit translation to the right of the original function. Okay, so let's look at another composition. Let's look at the composition which goes g f of x, g f of x. Okay, so that is to say, in function g, the x is replaced with the f of x. Okay, so not a whole lot to do there. All right, and you might wonder if that is another translation, and in fact it is. Okay, it is just the original function, okay, shown here in red, and the new function, which is pulled 4 units down. Okay, so in a sense, some of these compositions are resulting in giving us translations. Okay, that's not to say all, but these were. Okay, so we're just trying to paint the picture of relating the compositions of functions to something we already know. So some composition of functions are effectively producing translations of the original function. That's not all. Here's how I illustrated it on my calculator. Okay, I graphed one of the functions as the f, and the other function y2 is the g. Now this is simple entry. It's just write it as you see it. y1 of y2 of x. So that's essentially saying, you know, f of g of x or g of f of x. So so this is the previous. If we looked at the previous page, okay. Sorry about that. Okay, we looked at the previous page. Here is the f and g. So we're going to see that same thing. F being the let's see, that's being the quadratic. All right. So here, this is function f. This is function g. And what I'm asking to see is f of g of x, which is exactly what's shown. I asked the y3 with a style to be a little thicker, so f6 with the style will be a little thicker. Now here again, the same two initial functions enter, but now what I'm asking to see, as from what you can see I have checked, okay, is y2 of y1 of x. So that is g of f of x as compared to our previous slide, and there it is again, just in keeping with what we showed you before. Okay, Let's look some other compositions of such. Uh, and as I start this off by stating, not all compositions of functions result in translation. So, I mean, the previous 2 pages were showing that these compositions could result in translations, but that's not to say all compositions result in translation. So here we go. We look at a couple other compositions, okay? Um, so I say here, some will produce entirely new functions. So here we are with two quadratic functions, f and g, and we're going to look at their compositions either way, f g of x and g f of x. So f g of x, again, trying to show the color scheme here. Okay, all x's in f are replaced with the function of g, which is 2x squared minus 1x plus 4. So there you have it going in. There you have it going in for x with the 3x. Here you have it going in with the x, which is going to be squared. So there's a little bit of algebra, okay? A little bit of algebra. This trinomial needs to be squared, okay? Then the 5 is distributed, and then we need to distribute the -3. So here's the result of that. You know, you could ask your calculator. We're not going to be concerned about all the algebra behind that, but okay, we can look and see. It can be a little it's just a little bit burdensome with some of the problems. Okay, so the 2x squared minus 1x plus 4 squared it collapses to this expression. We distribute the 5. I guess we have some terms to tie together. So obviously you can see that the composition of these two produces an entirely different, produces a 4th degree polynomial. No relevance to either one of the originals. We look at the composition the other way around. G f of x, which could be just as algebraically frustrating in terms of what we got to do, but understand what it is. Okay, see, you're going to function g now. All x's, which are in blue, are replaced with the function f. Okay, there's a little bit of algebra to that, but I'll leave that to you to expand, and you could ask your calculator, but you'll see that it's not the same as this. Okay, in case you were thinking, can I do f of g of x and g of f of x and end up getting the same thing? Well, not here, but that question cannot be answered entirely yet, because maybe there will be occasions where that happens, and we'll see. Okay, so something to think about. All right. In some cases, we do what we call a composition of a function with itself. Okay, so in other words, I ask for f of x. This type of composition is called an iteration. But what does that imply? Well, okay, go to function f of x, which is 2x minus 5, and replace the x with itself, 2x minus 5. Do the little algebra to simplify it, and there you have it. Okay. Again, not any relevance to the original function. Okay. What if I wanted to do the composition again? F of x. Well, I've already got the dual composition. So what I could do is I actually could just take this as my result, and all my x's are replaced with the 2x minus 5, which is, or I could go to the 2x minus 5 and replace the x with the 4x minus 5, 15. I'd ask you to try it either way. So that gives us that answer, okay? A function in composition with itself is known as an iteration. The result of the first composition, that's the function with itself, that's the first iterate. This is the second iterate, okay? It's, okay? The composition of the function with itself once over is the first iterate. Composition of the function with itself again and then again is the second iterate. So we'll do this example with g now. Okay, I ask for the first iterate of g, which would be g of x. So algebraically, what's that mean? G of x is the x in g of x is being replaced with itself. So this x here is replaced with the function x squared minus 4x. And then it's going to have to be squared. Over here, okay, it is going to have to be distributed to 4, and we get down to this. Now, what would that's the first iterate. The second iterate would be, okay, going to that, all right, and this is the end of the first iteration, if you will. Now I have to replace all x's in there with the x squared minus 4x, and I'm saying I'm not doing all that algebra, okay? And in fact, you may not need to. It's just what is ending up being done in this particular problem, okay? And I'm going to be satisfied with saying this is an expression for the second iterate. I'm not carrying out all that algebra, okay? And that would be fine. You could do that if you had nothing better to do, I guess. Okay. All right. We're gonna cut it here and let you digest that a little bit. Okay, and we'll come back and do another video.